Welcome to another math video. For you math rock stars out there, today we're going to be talking about the approximation of pi. I'm excited, you're excited, we're all ready to rock and roll. Pi, circles. Those of you showing up late, you're just like the broom. Why did the broom always show up late? It overswept. It overswept. All right, we're going to investigate the relationships between diameter, radius, and circumference. All right, so we're going to look at what we know about the parts of a circle, and then we're going to develop an approximation of pi. You've heard that word pi 1,000 times. You may have even used it, but maybe you don't really quite understand what it means. That's what we're going to kind of dive in today. Okay, and we're going to do that based on our understandings of circumference and diameter of various circles. Okay, so first, here's our vocab word, pi. I'm going to kind of tell you what it is first and then kind of really dive into it afterwards. Pi is simply the ratio of the circumference of a circle to its diameter. So it's the relationship, the circumference. So we can take that circumference and we can divide it by the diameter and it will equal pi. Okay, and you see the symbol there for pi. If you want to, as you're looking at this, think about how you're going to grow your understanding of pi as this goes on, and that'll help you maybe draw a picture or develop what pi equals in your mind, a mental picture. Okay, so take a look at this picture right here. This is a circle rolling, okay? And you'll notice that the red from the circle is kind of turning into a straight line. And what it's meant to show you is the circumference. All right, so if we imagine that a circumference of a circle is the outside edge of the circle, right? It's the perimeter of a circle. If we imagine being able to unroll it, okay, it would be a straight line, and then we can measure it, right? We could tell how long the outside of the circle is. You know, for rectangles and squares and things like that, we could simply take a ruler and measure, right? It's a straight line. It's really hard to measure a circle. But this is just a visual understanding of what the circumference would look like, or the perimeter of the circle would look like if it was rolled out into a straight line, okay? Now, what do we know about the relationships of a circle? So there is a proportion that works with every single circle, okay? You kind of just did the vocab word for it, but we're going to lead into it. It's a ratio between the circumference and the diameter of a circle. So the circumference is what? It's the outside edge. And what's the diameter? It's the distance across a circle, okay, that goes through the middle, okay? I put radius in there as well because we're going to dive into that a little bit as well. But if you understand what diameter is, it goes all the way across and goes through the center. And you know what radius is? It starts in the center and goes all the way across. Then you'll understand the relationship between those two as well. So guess what? The relationship that we're talking about, the ratio, is that the circumference. So if we rolled out this circle right here that you're looking at on my screen and we rolled it out to figure out how long it was, it's going to be a little bit more than 3 times as long as the diameter. All right, so the diameter, if we took it and multiplied it by 3, just a little bit more than 3, we would get what the circumference is, okay? And so what does that mean? Well, that little bit more than 3 sounds a little familiar, right? A little bit more than 3 is like 3.14159265359 blah, 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 goes on forever, right? That irrational number of 3.14 pi. So what that mean? That means that pi is the relationship between the diameter and circumference. So pi is actually what pi is telling us. When you see that number, 3.14, you're saying that you understand that pi represents the ratio of circumference and diameter. It's telling us that if we take that diameter and we multiply it by pi, it's always going to give us our circumference of every single circle we do. Okay, so let's look at an example. Now, these 3 circles are all the same size. And I'm sorry that it looks this way. It's just easier to get it onto your screen. But I'm going to give you different circumferences and different diameters, and I want you to imagine the size of the circle as we do it, okay? So if our circumference is a bit more than 3 times longer than the diameter, then what that means is we can take the circumference of a circle and divide it by the diameter, and it should give us that pi proportion, right? So we do like the inverse of multiplication. We go ahead and divide them. It should give us our approximation of pi. So for this one, we're going to say the circumference, or the distance around that circle, is 12.56. And we're going to say that the diameter is 4. If we take the circumference and we divide it by diameter, if we divide it by diameter, it's going to give us, yep, 3.14, or pi. This other one's a bigger or a smaller circle, I'm sorry. The diameter is only 2. So let's just imagine it's 2 inches across. And we know that the circumference is 6.28. If we divide them, 3.14. This is a huge circle, right? It's 10 inches across, way bigger than the other ones. It's got a circumference of 31.4, but if we divide them, it's 3.14. Okay, but what happens if you only know the radius? Okay, so if it gives us the radius and circumference, so look at these scenarios. Can we solve them from here? No. Yes. What's the relationship we know about radius and diameter? Because we know in that last slide, all we did was take circumference divided by the diameter. Well, we need the diameter again. How do we find the diameter? Well, it's twice as much as the radius. So with each one of these problems, we're just going to double the radius so we know the diameter. So the circumference is 12.56, and this one says that the radius is 2. If we double that, what do we get? We get 4. Okay, and when we double it, what we're doing for ourselves is saying that we are going to now be able to divide 12.56 divided by 4, and it gives us our proportion, which is 3.14. This one, we take 1, and we multiply it by 2 to get our diameter, which is 2. And we do the same thing. We divide, and we get 3.14. This one, the radius was 5, and we doubled it to get to 10. So we divide, and we get our proportion. It's every circle, and I know I gave you some very similar numbers, but you can do it with any circle that's ever existed, and you will find the proportion, or the ratio, the proportion for the ratio circumference equals, circumference divided by the diameter. It's always going to give you that pi answer. Okay, so let's go ahead and fill in some blanks. The diameter is what compared to the radius? It's twice as long. There is a proportion between the lengths of the circumference and diameter. It is about 3.14, and it is called what? It's called pi. Or you could even draw the symbol if you'd like to, okay? And it's about 3.14. It's not exactly 3.14, it's about 3.14. Every circle has the same pi blank between the circumference and diameter. It's the same pi relationship, or the same pi proportion when you figure out the circumference and diameter. And then finally, you already answered this one, but I want to put it on here twice because it's twice as important. If we already know the radius, or if we only know the radius, we can do what to it to find the diameter? We can double it. There you go. Approximation of pi. You're going to need this as we go forward. Okay. How do you warm up a room after it's been painted? Yep. You give it a second coat.